So we're, again, finishing section 15.1, then we're going to start 15.2, and then we're going to do something separate from the book. Okay, our histogram is for classes go from 80 to 85. The next one from 86 to 91. And 92 to 97. And 98 to 103. Frequencies are going to be 3, 2, 4, 6. Okay. I like to put the classes on the horizontal line and then the frequencies on the vertical line, but it doesn't really matter which is which. Okay, we're going to label these markers 80, 86, 92, and 104. And I'm going to put a little space between 0 and 80. Marker 86, 92. And 98, 104. And then for our frequencies, the most we have of our units is 6. So I need a place where I can put 6 on this. So let's cut it in half, and that's 3, 4, 5. Okay, so in a histogram, your bars touch. And we're going to go from class to class. First one has a height of 3. So from 80 to 86. Then next class has height 2. Now we're at a height of 4 for the third class. And the last one has height 6. We're going to do one more of these and then move on. Let's put draw. We're going to draw a histogram for the following table. Our classes, along with the frequencies. The first class is from 20 to 29 with the frequency 10. And we're going from 30 to 39. And the frequency is 7. From 40 to 49. Frequency of 3. The last one goes from 50 to 59. And the frequency is 1. Okay, this way I like to put the class, and this way frequency. And I'm going to put a little space here. And then start at 20, then mark 30, 40, 50, and 60. This time, the most you have for frequencies is 10. So I'm going to start there. Go halfway is 5, and then kind of label 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, first one all the way up to 10, between 20 and 30. That's your 32 up to, but not including 40. We have height 7. Between 40 and close to 50 is height of 3. And from 50 to almost 60, but not including 60, just height 1. That's it. Later, oh, I have a question. Cool. Okay, cool. Yeah, feel free to work in groups. It's cool. Just make sure when you submit, like later on in the semester, when you submit responses to an exam, please just put it in your own words. It's a little clear when someone has the exact same words as someone else. Okay, back to notes. And I guess I wanted to mention, probably not today, but in this chapter, we're going to talk about shapes of distributions. And we'll take something like a histogram and look at its overall shape by drawing a little sketch close to the bars, but not, just a little bit touching these bars. And it comes up and down and over. So later we'll know that when this, what we call a tail, is on the, see, to me it's on the right side, this would be right skewed. And then there's left skewed and other types of shapes, but we'll get there, like I said, soon, not today. For now, we're just sticking with the histogram with your bars that touch. Across the class. For section 15.2, Main topics are mean, median, mode. All right, so in 15.1, we started talking about sets, and they were mathematical sets. So recall in the sets that we talked about before, there's no order and duplicates are not counted. Okay, so what we're going to start talking about now is more of a list instead of a set, but it's kind of called a set, but it's not really a set. It's a data set. Okay, this is a collection of numbers that represent values obtained from a population. Kind of paraphrasing what I wrote. So overall, I have a data set is a collection of numbers that represent all of the values obtained when measuring a characteristic from a population. I think I'll try to draw a picture, but it's kind of like the same idea, but we're getting more into statistics stuff, like doing a study or an experiment, and you're looking at a group of people or a population of something, and you are interested in a certain characteristic from that population. So you find all of the values from all of the numbers that represent the characteristic of the population. So it's not a math set. Like a mathematical set. Because repeated numbers are included. All right, again, it's not a mathematical set. It is more of a list. That we're going to put in curly brackets. All right, so kind of a quick picture, just a sketch of the difference between these guys. In 15.1, we talked about a set, and we drew the universe as a square. It could be a big circle, but it's kind of like the style to make it a square. And we had elements inside that weren't repeated, like 1, 3, 5, 9, 12. And then we're switching it up a little bit. In 15.2, we have a population. And in the stats classes, in the stats books I've looked at, it's usually a big circle for your population. And you're interested in some kind of characteristic from the population. Like we had an example where we asked how many cats someone owned. And let's say the first person owns 2 cats and the next person, maybe there's 5 people total. This person has 2 cats, this person has none, next person has 1, the other person has 2, 3, 4, 5, 1, 2, 3, 4. Last person has, let's say, no cats again. So there were 5 people. We've gotten a measurement of the characteristic from each person, and there are repeats. And this is for a data set. Well, there's no dash, it's just data set. Alrighty, so we're going to, let's just jump right into some notation. Okay. It looks intimidating, but the idea is kind of easy. So we're going to start with a set. Let the set that contains x sub 1 followed by x sub 2. The next one we call x sub 3. It would go x4, x5, all the way till the end where you get to x sub capital N. And this is a set of n numbers. And again, x sub 1 is the first number in the list. X2 is the second number. X sub I, we call the ith number. Then we're going to sum from I equals 1 to n, all of the values in the set, all of the x of I. Okay, so this symbol means sum. We go from I equal to 1 all the way up to capital N for x sub I. So for sum, it means to add x1 and then move to the next value for I, which is x2, up till you get till the end, x sub n. So x1 plus x2 plus x sub n. Okay, in words, it means add all of your data values together. Let's see, for the data set, that contains 1, 2, 1, 3, 7, and 9. We're going to find the sum. There's 1, 2, 3, 4, 5, 6 of these. So we're going to go all the way up to 6 for capital N. Any value x sub I. So in the past, people have said this looks really strange, and I agree. But the idea is kind of simple. Add this with this with this. Add all of your data values together. That's what this is asking. Okay, so your sum from I equals 1 up to 6 of x sub I. Let's just write it out as x1 plus x2 plus x3 x sub 4 x sub 5 x 6. Okay, looking at your list, this would be x1. Here's x2. x3, x4. And that's the 5th one and the 6th one, x sub 5 and x sub 6. Okay, so putting in 1, add 2, add 1 again, then keep going. So I'm going to take this part as 10. Here's another 10, shoots me to 20, 21, 22, 23. I have 23 as the sum. Or the data set that contains 2582, find the sum. So it's a summation sign, and you're going to start at I equals 1. And there's 1, 2, 3, 4 of these. So we're going up to 4 as our last value with x of 4. Let's also mark these guys. This is x1, here's x2, here's x3, last one's x4. Okay, working through the problem. Take the sum from I equals 1 up to 4 of x sub I, which means put in the first one, x1, add putting in the next one, x2, then there's plus x3, and then the last one's x4. So we're putting in 2 plus 5 plus 8 plus 2. And again, this would be like 10, 15, 16, 17 as my sum. Okay, and there is another way to write this. It's still the same idea. It's just like a little cleaner. I don't know how else to say. Like notation for the sum from I equals 1 up to n of your x sub I. It's also written as just the sum of all I for x sub I. And again, the idea is sum your data set. Okay, so for the following data set, we'll find the sum. Cool. So our set's going to contain 7, 4, 6, 2, 6. Then we have -3 and -6. We want to find the sum of all I for x sub I. Okay, so we're going to sum all of our x of I values, which means take the first value, add it to the next one, 7 plus 4, then go plus 6 plus 2 plus 6. And we're still going to add -3 and add -6. Which I'm going to keep in parentheses just to make sure I don't make any mistakes. It looks good to me. So let's go ahead and simplify that answer. See, there's a +6 and a -6, so it's gone. Let's put this -3 with 2 to be -1 at the end. Keep that 7 right there, and then +10, and this was -1, and that +6 and -6, 0. Okay, 17 minus 1 is 16. Okay, so I'm going to keep on doing a few more examples, mostly to get used to the notation. For the data set, that contains -20, 0, 4, and 7. Find the sum of all I for x of I. Which is written sum all I for x sub I. Okay, take your sum of all I values for your x sub i's, which means for every data value in this set, add them together. Start with -20, add 0, add 4, add 7. Okay, -20 plus 11, it's going to be a negative number, and I'm going to do some scratch work. The difference between 20 and 11 would be 9, but we're going in a negative direction for -9. One more for summation notation. For the data set, that contains negative 22, negative 10, negative 4, and 2. And then close the set. Find the sum of all I for x of I. Okay, sum your I for x of I by taking the first value, negative 22, add the next number, negative 10. Continue to add, negative 4, and then add 2. And simplify your answer. So this is a negative 22 with negative 10, right? Negative 32. Let's put this negative 4 with positive 2, which is negative 2. It's negative 34. Okay, so let's before, when we had the other notation, there was that capital N. And I just want to restate what capital N represents. So let capital N denote the total number of values in a data set. So the next step, let's see. Yeah, it's a definition, or maybe next idea is the average of a data set. So just to let you know, average is also called the mean. So if I say mean, mean means average. And you find the average or the mean by summing all of your values and dividing by the total number of values. And it looks weird in math, but still, you sum all I from 1 up to capital N of your x of I. So like we just practiced, take that number and divide by the total number of values in your set, capital N. So we're going to continue on from that statement. What it means, in words, is sum the data set, then divide that number and divide by the total number of values in the set. Which means divide by capital N. Capital N is the total number of values in your set. Okay, so we're going to find the average of the data set. That contains 15, 20, 25, and 60. And then before we get going on this, on the side, just want to say that I think that instead of doing the percentiles, we're going to replace it with a few other ways to graph and then put all of these ideas together in our graphs. And when we draw a graph, let's say for a histogram of a data set, and then we find the average, it will show us sort of where the center of the data is. So it kind of is a marker for is a measure of center for your data set. Again, it'll kind of be more clear when we draw our graphs and like label the mean. Okay, for now, we're just going to get the average as the sum of all of your x sub I and we can put the part where we go from 1 to n, divide by capital N. There's 1, 2, 3, 4 of these, so we're going up to 4 for n. Actually, we'll put this as the next slide. Okay, and then put in your x1 and x2 and x3 and x4. Add it all together. x1 is 15. Add 20. Add 25. Add 60. Divide all of that by 4. So like 35 plus 85. 120 out of 4 would be 30. Okay, we're going to find the average again. Okay, our set this time includes or contains 0, 1, 0, 1, 5. 0, 2. And then close your set with the curly bracket. We're getting the average, which means sum all of your x sub I from I, x sub I, from I equals 1 up to n. And then divide by n. How many do we have? This is 1, 2, 3, 4, 5, 6, 7 elements total. So capital N equals 7. Okay, we're at summing all of the values in the set. So we want to take 0, add 1, add 0, plus 1, plus 5, plus 0, plus 2. And divide that by 7. What do we got? 1, 2, 2 plus 5 is 7, 8, 9, 9 over 7 is good enough. Also, it'll kind of be clear in your homework, but on a test, if you write your answer as a reduced fraction, that's fine. If you want to put it as a decimal, that's okay. Just try to simplify your answer if you can. Continuing to practice, but I'm going to ask for the mean, which is the same as asking for the average. For the following data set, find the mean. Seven here. It is the set that contains -5, 10, -13, and 2. Find the mean. Means the same as average. And we sum x sub I. I'm just going to put sum x sub I for all I. And then divide by n. Let's move up to the top of the board, going up. Over. So in the numerator, we're adding -5 with 10 and -13 and 2. -5 plus 10 plus -13 plus 10. And divide by n. Capital N is the number of elements in your set, which you have 1, 2, 3, 4 elements total. This -5 and 10 is 5. Oh, that's, well, we can leave that there. -13 with +2 is -11. And then 5 minus 11 will be -6. And then I can simplify my answer. Don't forget that minus sign. But 6 is 3 times 2. 4 is 2 times 2. Whenever you see a number over itself, it reduces to 1. So 2 over 2 is 1. So you have -3/2 times 1, which is -3/2. Cool. One more. Find the mean. Of the data set that contains negative, oh, we did that one. Okay, we're here at 0.5 and 2, 8.5, 10, 15.5, and 26.5. That's it. So the mean is the same as the average. Where you sum x sub I, all I, and divide by n. Let's do this here. 0.5 plus 2, but I think it can all work out. 0.5 add 2 add 8.5 plus 10 plus, I'm just going to move this up. Plus 15.5, add 26.5. There are 1, 2, 3, 4, 5, 6 elements total. Here we've got 2.5. That's here, 18.5. The last two together would be, let's see, here, 7. Let's see, I got 42. And my numerator wound up being 63. And then divided by 6. And then I simplified my fraction. 63 is 21 times 3. And 6 is 2 times 3. When you have 3 over 3, it reduces to 1. And what's left is 21 over 2. Oh, let's make sure we have a timer for class because I have tons of notes. Okay. We're at the median of a set. Okay. It's the value in the middle of your list after putting your list in increasing order. So the median of a data set is the value that lies in the middle of the data set when arranged in increasing order. So there's going to be kind of 2 steps, but in the second step, there's 2 options. So first step, you need to arrange your data in increasing order. Okay, so in the second step, you start to find the middle of the list, but 2 things could happen. There's either 1 number in the middle or 2 numbers in the middle. So if the number of values in a set is odd, then the median is exactly in the middle. Okay, just a moment. Yes. Are you outside? Do you want in the closet for some reason? Yeah. we're almost out of time. So hopefully we can just finish these instructions and then we'll practice when we come back Thursday. So either you have an odd number of values in your list and you go to the middle and the number's right there in the middle. Or you have an even number and you go to the middle and there's two numbers. So if the number of values in the set is even, then the median is the average of the two middle values in the list. So this time you have your list in order. We'll go to the middle and there's two numbers there. We'll add them together and divide by 2, find their average, and that will be the median. So we'll practice when we come back on Thursday. We are done with class for today.